Okay, number 7. I'm deciding you don't have to sketch the graph because it has a slant asymptote, which we didn't discuss, but we will go through all the steps up to sketching, but just don't sketch it for the practice. It's got other good practice in there. Domain all x such that x is a real and x cannot be 3 because 3 makes the denominator 0. So I'm saying all numbers except 3. You can say that any way you like. That's how I choose to write it with a proper notation. B is to find the x and y intercepts. I plug in 0 for x to get the y intercepts, and I get 8 over negative 3. I plug in 0 for y to get the x intercepts. I just care about when the top is 0 for a fraction to be 0. So I can just solve that. The way we solve a quadratic is to typically try and factor it. So this is a trinomial where a is 1. I'm looking for numbers that multiply to 8 and add to negative 5. So I can't find any. So then from here, if you can't factor, you could, on a quadratic, you could always do the quadratic formula. So your a being 1, b is negative 5, c is 8. What I'm going to do is just do the b squared minus 4ac part for a second, just to check if I need to carry on. I'm getting a negative number for b squared minus 4ac, and then I would try to square root it, right? Because this is the part that's under the square root. Can't square root a negative, therefore there are no real x's that solve this quadratic, meaning there are no x-intercepts. C, we need to do our asymptotes. Vertical is pretty much the same thing as the domain for rational functions. We've got a vertical asymptote at x equals 3. Horizontal, we have none because the degree up top, the degree of the numerator is 2, the degree of the denominator is 1. Whenever this is the case, there's no horizontal. There could be, however, a slant asymptote, but we didn't talk about that. And in fact, there is one, but we're not going to find it. D, first derivative test. F prime times g minus f g prime all over g squared. So I want to simplify this thing. In the numerator, I guess I will multiply these two things together. I'll distribute the negative, so essentially multiplying those things, and then collect to make one big quadratic. So I've got 2x squared minus 6x minus 5x plus 15 minus x squared plus 5x minus 8. So the x squared is 2x squared minus x squared is x squared. So I did those. The x's, I got negative 6 minus 5, that's negative 11, plus 5, negative 6. And then 15 minus 8, plus 7. That's my first derivative. So whatever makes the top 0 and whatever makes the bottom 0 are my critical values. So there's 3. Over here I try to factor. It's a trinomial. Numbers that multiply to 7 and add to negative 6. Negative 7 and positive 1, almost, but that gives you negative 7 when you multiply them. So again, I can't find any. So what could I do? I could do the quadratic formula because it's a quadratic. A is 1, B is negative 6, C is 7. First, I'm always going to check the discriminant just to see if I need to waste my time. If the discriminant comes out to be negative like above, then there's no real solutions to that quadratic, so I would get no critical values from that. So b squared is 36. A is 1. C is 7. 36 minus 28. So that comes out to be positive. So that looks like we are okay. there will be zeros from this. So 36 minus 28 is 8. So now I'll put that into the quadratic formula. So x is going to be negative b, so negative negative 6, plus or minus the square root of 8 over 2a, so over 2. The square root of 8 would be 4 times 2, so the square root of 4 is 2, so it could be 2 root 2 over 2. And then the 2 can go into each one of these. So those are my other critical values. 3 plus or minus root 2. Let me see what those come out to be. Give me a second here. 3 plus the square root of 2. Let me see, I don't know what this thing. 2 square root plus 3. That's about 4.4. So we've got x equals approximately, I should say is approximately 4.4 is another critical value. And that was 3 plus root 2. Now we'll do 3 minus root 2. We get approximately 1.6. So those are our critical values for the first derivative test. I'm getting 1.6, 4.4, and 3. So if I plug in 0 into my derivative, the bottom up here will always be positive. And so for the top, if I plug in a 0, I get a positive. I could plug in a 2 up top and get 4 minus 12 is a negative 8 plus 7, so that's a negative. I can plug in, oh boy, that's interesting. 4.4 comes after 3. So I still plugged in a 2, which is fine. The 4 minus 12, negative 8, yep. Then I plug in 4 in the next interval. 16 minus 24. So that's going to be a negative 8 again. Plus 7. Right? Let me just confirm that I did that right. 16 minus the 24. Yeah, that's negative 8 plus the 7. Then if I plug in a 5, got 25 minus 30 is the negative 5 plus 7, that's a positive. So that was telling us extrema. At 3, there is an asymptote. So I'm going to say f of x is increasing from negative infinity to 1.6, union 4.4 to infinity, decreasing 1.6 to 3, union 3 to 4.4, because there's an asymptote at 3, so I have to break it up, has a max at 1.6, whatever the y value, and a min at 4.4, whatever the y value of the original. So you got to plug those into the original. So f of 1.6 and f of 4.4. I'll let you have fun with that. You guys can figure those out. Not a problem. When you figure them out, you fill them in there. There's your max and your min, because we're not graphing. So, yeah, good luck. You'll do just fine with that. Our derivative is x squared minus 6x plus 7 over x minus 3 squared. So for our second derivative, got f prime times g minus f times g prime. So, whoops, 2x minus 6 times x minus 3 squared. I'm going to bring that 2 to the front. I'm going to common factor out an x minus 3. Oh, wait a second. I can call this 2 times x minus 3 if I factor a 2 out of that. Then it's times x minus 3 squared, right? So what I'm going to do is just call that x minus 3 cubed. Minus 2 times x minus 3. I'm just switching the order over here. X squared minus 6x plus 7. So now I can common factor out a 2 times an x minus 3 and get x minus 3 squared minus x squared minus 6x plus 7. That's all the numerator, so that's all over x minus 3 squared squared. This guy will cancel with one of those guys. I'm going to simplify inside the parentheses. So x minus 3 squared is going to be x squared minus 6x plus 9 minus x squared plus 6x minus 7. Simplifying that guy. The x squared minus the x squared, the 6x minus the 6x. The 9 minus the 7 is a 2 times the 2 that's out front. We've got 4 over x minus 3 cubed. The only critical number there is 3. So if I plug in a 0, I get a negative. If I plug in a 5, I get a positive. So f of x is concave down from negative infinity to 3, concave up from 3 to infinity, and has no points of inflection because at 3 it is a vertical asymptote. That is number 7. Let's see if I can get number 8 on there. Now we're at 12 minutes.